Okay, so I'm going back to section 3.5, and that will be section 3.5. Okay, and that will be video 2. Video 2. Okay, so last time we talked about vertical shift. We talk about the example y it's equal x squared and function g of x, which is equal x squared plus 3, and we had that vertical shift 3 units up. So next what I want to talk about vertical shift down. So vertical shift down example. Okay, so use the graph. Just trying to figure out which one will work better. Let's try with this. Use the graph. F of x equal x squared to obtain the graph g of x which is equal x squared minus 4. Find the domain and range. Of g of x. Okay, so what happened here? G of x is a vertical shift of f of x by, in this case, you see negative 4, which means 4 units down. So vertical shift means that we're going to use the graph of f of x, and we will use the same x values, and the y values of original graph will be pushed down 4 units. Okay, so let's graph it and compare. So let's go back. We graph f of x before. We had 3 points, 0, 0, that's from previous example, 1, 1, and negative 1, 1. Okay, so g of x, which is x squared minus 4, to graph it quickly, you will use exactly the same x coordinate. The y value, because you have that negative 4, will change by taking original y value, which was 0, and you will just subtract 4. So that will give you 0, negative 4. This point right here, originally, which was 1, 1, will have exactly the same x coordinate, which is 1, and the y value of function g, take original y value of original graph and just subtract 4. And that will give you 1, negative 3. And this point right here, because we have that vertical shift down 4 units, will have exactly the same x coordinate, no change here, and the y value, take the original y value and subtract 4. And you end up with -1 comma -3. So I'm going to graph both of them, f of x and g of x, so we can see that vertical shift 4 units down. So let's graph it. Okay, 1, 2, 3, 4, and so on. Here. Okay, so f of x. F of x, we have point 0, comma 0, 1, comma 1, -1, comma 1. This is our parabola. Okay, little off, but that's fine. Okay, so this is f of x. And let's graph g of x. We have point, like you see, original graph. We're pushing each point 4 units down. So we have 0, -4, 1, 2, 3, 4. Then we have 1, comma -3. This one, this point right here was pushed. It's going to be pushed 4 units down. So 1, comma -3. And then -1, comma -3. Okay, so the purple is g of x. Okay, vertical shift down. Four units. Okay, so when you have new graph which looks like original graph, but you have a coefficient standing alone, that means that you have vertical shift or up or down. You see negative numbers, so it's going to be vertical shift down by 4 units. Now the problem asks you to find the domain and range of g of x. So domain of g of x is the same as domain of original graph, since x coordinates were not affected, which is all real numbers from -infinity to +infinity. Range, that's the y values. Range of g of x, again, since that graph was pushed down 4 units, will be different than the range of f of x, and is from, again, that point was -4, from -4 to +infinity. Okay. Next, what we're going to talk about it, we're going to talk about horizontal shift to the right. Okay, so next will be horizontal shift to the right. So horizontal shift to the right, this is what's going to happen. F of x is original function. Yes?